In this video, we're going to cover how to write unit tests in C# and VB.NET, and we'll also explore end-to-end testing with WPF, which enables us to automate and test user interface. Hey guys, and welcome to Zoo Coding. To save time, I've gone ahead and set up the UI controls for a simple calculator app that we'll be writing tests for. All the code in this video is available from the link in the description down below. I'll be writing a test in C# today, but there's a VB.NET version available from the link as well. Let's get the application set up first of all. Today I'll be using a WPF app, but you can follow a similar sort of process for most Windows apps created in Visual Studio. If you have a console app, you can still follow along with the unit tests, but the end-to-end tests won't apply to you. I've got a simple calculator interface that I've set up here. Essentially, the user enters two numbers and uses the buttons to perform a calculation, with the result appearing below. I've also set up a calculator class that has functions to add, subtract, multiply and divide numbers. It's a good idea to keep this as a separate class in the main window, so we can easily reference it in a unit test later. In the code behind for the main window, I've defined a click event handlers for the calculation buttons, and a perform operation function that simply calls a relevant function from our calculator class, along with the user's input. Now that our app is ready to be tested, we can create our test project. You can do this by going to View, Solution Explorer, and right-clicking on the solution here. Then go to Add New Project. Today we'll be using the XUnit framework, so search for XUnit here, selecting either the C# or VB option. You can then go ahead and give it a name, such as Test Suite. It's important to make sure the version of .NET is the same for your application and the test project. You can check this by right-clicking on the new project in the Solution Explorer and clicking on Properties. We can set the target framework here, which matches the application, but because I've got a Windows WPF app, I'll need to set the target OS to Windows. The next step is to add a project reference to our main application. Right-clicking on the Dependencies option under our test project and clicking on Add Project Reference. We just need to make sure our main project is ticked here. We can then create the class files for our tests. I've gone ahead and created two class files here by right-clicking on the test project and going to Add Class. But it's up to you if you want to organize this a bit better with folders, or even a separate project for both types of tests. Now we've got everything set up, let's start writing some unit tests. We can start by creating a function in our unit test class to check if the add function returns the correct sum. The standard naming convention is to start with the function, in this case add, followed by an underscore, and then should do something, for example, return correct sum. I'm then going to call the function to add 1 and 2 together, and then I'm going to say assert.equal, passing in the number 3 and the result variable. We're essentially saying that 3 should equal results here, and if it doesn't, the test should fail. Let's add the fact attribute to this function to tell XUnit that it's a test, and then we can run it. To do that, you can either go to Tests in Visual Studio and run all tests, or open the Test Explorer. Here you can see a list of all tests and run them individually or by file, and when I run the test, we can see it passes. Now we can either repeat this function with different test data, or we can reuse the same function with the theory attribute, like this. Here I've added the parameters for the two input values and the expected result. I've then defined the test data with inline data attributes, specifying a set of parameters. Because we're using decimal values, it's a good idea to set the decimal point precision to 1 here. Let's see what happens when one of the tests fails by changing one of these expected values. When we go to run the test, you can see there's a failed instance of this test along with the error. At this point, you can try and debug the test by adding in a breakpoint here. I'm running this particular instance again using the debug option this time. This lets us inspect the values and see what's going wrong. Let's revert this value back and write another test. This time I'm checking to see if the add function can handle large values correctly. I can now use assert true and assert false to check if a particular boolean value is true or false. And the last test I'll write today is to check if the divide function correctly throws an error if we are divided by 0. Here we can use assert throws with the type of exception, argument exception in this case, passing in a callback function that should return the error. We can take this one step further and confirm that the message is what we're expecting too. Let's run all the tests one last time. And there we go, they're all passing. Let's now move on to write end-to-end tests for our UI. To be able to easily identify parts of the user interface, we need to add automation ID properties to our controls. I've done this for the text boxes, buttons, and the text blocks that contain the result and error message. In our UI testing class, we first need to get the path to the executable of our application. This will be in the binary folder. You can go ahead and copy this into your project, but just make sure to change these variables to match your app's name and the title of your main window. Let's create the function that returns the application at the start of each test. We'll first check if our executable exists, and if it does, we'll start the process to run the app, along with a 2-second delay to give the app some time to load. We'll then create a while loop that will keep checking if the app is ready yet, and I've set a maximum of 10 retries here. We can then create a property condition on the root element, which is the desktop, to see if it has any windows that match the title we've got. These windows will essentially be children of the root element. If the result isn't null, then we have our window, but if it is null, we'll wait half a second before trying again, and throw an exception if we run out of tries. Let's continue creating our next helper function that will find an element by automation ID. Remember from earlier, these are the properties we set in the designer to identify controls in the UI. We'll start with a quick null check and then define a similar property condition to before. But instead of looking for windows, we're looking for controls, which are the descendants of the window element. We can then return the element, or if it's null, meaning there's no element with the given ID, we'll throw an error in this case. Now let's see how we can click a button in the UI. We can do this by checking if the button can be clicked programmatically, achieving this by getting the invoke pattern for the button. If we have an invoke pattern, we can call invoke to click the button, and if not, we'll throw an error. We can do a similar sort of thing when it comes to setting a text box value. Instead of invoke pattern, we use value pattern, and instead of invoke, we call set value, passing in the string value. And conversely, to get the value again, we can simply return the name of the current automation element. This will work for getting the value in a text box, or even the value of a text block, useful for getting the calculation result shown on screen. The last function we'll write before our test is the dispose function. Here we're simply going to close the window, end the process, and clean up any other resources. So the first test we'll write is to see if we can add two numbers up and see the correct result in the UI. We'll start by calling our first function, and then we'll get the elements for the two text boxes, the add button and the text block for the result. We can then set up the text box values to be two numbers, and then click on the add button. After a delay of half a second, which should give us enough time for the UI to update, we'll get the value of the result text block, and use assert equal again to see if the result is as expected. Let's run this test to see if it passes. And it does. Let's finish off with one more test to see if we get an error when divided by 0. As you can see, when I run the app and divide by 0, a message appears at the bottom here. We can do a similar thing to before, calling our start function, defining the elements for the text boxes, divide button and error text block, filling in our values and clicking the divide button. Then we can add an assertion to say that the error text block should equal cannot divide by 0. Let's test it out. And there we go, we were able to write both unit and end-to-end tests. If you're looking for some example apps, I've created a suite of desktop and Android apps that are all open source. And I've also made a language insight book with Levity that's 100% free. Check them both out in the description down below. Be sure to leave a like if you enjoyed this video and subscribe to keep up to date with latest reviews of coding. Thanks for watching and I'll see you soon.